asteroids and comets are really interesting to us because they're leftovers from the formation of the solar system. So they help us learn about history, but they're also really important to Earth because they occasionally come and hit Earth. Right? So we think that the Jovians can nudge the orbits of the asteroids and comets and send them to the inner solar system. Think of all the Earth-crossing asteroids we saw in the video, all of the red dots. So the Jovians did and still are playing a large role in sending objects our way. But there's another possibility. A lot of these Oort cloud comets can also get nudged when another star comes close to our solar system. So even though the star isn't close enough to affect Earth, it might be close enough to throw a comet at us. So some of these will plunge back into the inner solar system and possibly hit Earth. An interesting thing about impacts is the impactor comes in 10,000 kilometers per hour up to 100,000 kilometers per hour, just how fast Earth's gravity has pulled that object. The impactor will vaporize on impact, and that explosion from the vaporization blows out the crater. And the vaporized material will rain down around the crater. Best part of this story, NASA has a railgun to simulate these. So the metal ball is going to get shot from the left towards the sand pit, 15,000 miles per hour. The impactor gets vaporized and digs out a little sand crater. Can I put this railgun on my Amazon wish list? Impacts in the early solar system would have been amazingly common. Earth was formed through impacts. But now that Earth's orbit is pretty cleared out, right, there aren't that many Earth-crossing asteroids, we can kind of think about the probability of ending up dead from an impact. Right? Getting hit by an impact is less likely than getting struck by lightning. There are no confirmed reports of a human actually dying from an impact. So this graph is from your textbook, and it looks at the probability of different impactor sizes hitting us, so small objects to large objects. So small objects hit Earth fairly frequently. Right? Grains of sand are always falling into Earth's gravity and falling into our atmosphere. Larger objects are much more rare. One example of an atmospheric explosion is Tunguska. And Tunguska is a region in Siberia. And in 1908, a large chunk of its forest was just flattened. The best explanation for this is that an object, be it an asteroid or a comet, we don't know, was probably a couple hundred feet across. And as it was coming into the atmosphere, it gets hotter. And this one never made it to the ground. It exploded a handful of miles above the ground. And the shock wave from the explosion flattened a huge part of the forest. Seeing as how this was in Siberia, there's no record of anybody being hurt. But if this had happened over a city, it could have destroyed a whole major city. The example we have for mass extinction is the dinosaurs. So we do know of the crater that dates to the time when the dinosaurs died. And it's here in the Yucatan Peninsula of Mexico. There's Florida. And the crater is half on land and half in the ocean. So here's the crater. And geologically, it has been dated to about 65, 66 million years ago. In order for this crater to have happened, the incoming asteroid or comet would have been at least 6 miles in diameter. Right? There's quite a lot of evidence that this killed the dinosaurs. Not only are most of the fossils dated to 65 million years ago, but a lot of the fossils lie with materials that only come from asteroid and comet impacts, such as iridium and some other heavy metals. When the dinosaurs went extinct, 75% of species went extinct. So that sounds bad, but not too bad. But then look at it this way. 99% of all organisms died. So just a few members of some of the species survived. Let me tell you a little bit about Comet Shoemaker-Levy 9. So in the 90s we had Comet Shoemaker-Levy 9, and it got close to Jupiter, and the tidal forces of Jupiter snapped it apart, so it broke into different pieces. And now the pieces all have slightly different speeds and slightly different distances from Jupiter. They're going to spread out and form a line. Right? Here's a picture of Shoemaker-Levy 9 before it hits Jupiter. And they're going to hit Jupiter one after another after another. Bam, 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 bam. And here are the impact marks on Jupiter as the comet went in and hit Jupiter. And this was really exciting. We had never actually seen a comet slam into Jupiter and actually stir up the ingredients so we could actually see what was underneath the cloud layers. And each of these impacts would have been megatons worth of explosives. These were powerful impacts. Comets will often fall into the sun. So here's the surface of the sun is this white circle, but it's been blocked out because the sun is so bright. We want to be able to see the fainter objects. There we go. It may seem like the comet caused these solar eruptions here and here, but it would have just been coincidence, right? The sun would barely have even noticed that a comet fell into its surface. These sort of large eruptions have to be driven by the magnetic field of the sun.